In a daring proclamation, scientists have declared the identification of a completely novel planet, distinct from any previously discovered. NASA, renowned for groundbreaking investigations, has revealed that this recently detected planet is captivating not only due to its dimensions and location, but also because it radiates a glow that seems unnatural. Could this revolutionary find signify that we are nearing the threshold of unraveling enigmas that could dramatically transform our understanding of the universe? Does this exposure imply the likelihood of existence beyond Earth? As we explore NASA's astonishing findings, we might soon bring to light the reality behind these exceptional illuminations. In 2007, NASA initiated the Dawn probe with an objective to explore some of the most enthralling entities in our solar neighborhood. Fitted with 3 ion thrusters, Dawn began a voyage that started with a 14-month examination of Vesta, the second largest rock in the asteroid belt. Dawn relayed detailed visuals and metrics, unveiling Vesta's intricate terrain and abundant geological legacy. Upon wrapping up its objectives at Vesta, Dawn advanced to what may be considered the most thrilling segment of its expedition, an intensive analysis of the dwarf planet Ceres. Thanks to its ion propulsion, Dawn succeeded in escaping Vesta's gravitational grip and proceeded towards Ceres, something conventional fuel-driven systems could not have managed. These thrusters provided a continuous push, allowing Dawn to traverse immense spans and attain a consistent orbit around Ceres. Spotted in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the most substantial object within the asteroid zone situated between Mars and Jupiter. For decades, it was viewed as the tiniest dwarf planet in our system, until its reclassification in 2006. With an approximate diameter of 950 kilometers, Ceres stands as the biggest and heaviest body in the asteroid belt, making it one of the most fascinating due to its unique attributes. Experts impatiently anticipated the inaugural high-resolution visuals of this enigmatic realm, which displayed radiant patches dispersed across its facade, notably within a prominent crater called Decatur. These luminous areas instantly sparked immense curiosity within the scientific arena. Before the Dawn endeavor, our best glimpses of Ceres were fuzzy, low-quality photos captured by the Hubble Space Telescope. There was minimal knowledge about this dwarf planet, and the opportunity to gain detailed visuals promised exhilarating revelations. The mission of Dawn sought to expand our comprehension of how the solar system came into being and the significance of water in crafting planetary entities. The gleaming regions on Ceres, also spotted on other space rocks, were believed to consist of highly reflective materials, perhaps salt deposited from evaporated water. This hint led to the possibility of cryovolcanism on Ceres, an occurrence where eruptions release not molten lava, but liquid water or salty mixtures. What these puzzling illuminations truly are, and what secrets they might disclose about Ceres, remains an unresolved inquiry. Might they be indications of present-day geological action, or do they point to something even more phenomenal? Ceres differs from other asteroid belt inhabitants because of its volume, weight, composition, and likelihood of harboring water and frost. As opposed to the typical stony asteroids, Ceres has a composition that mirrors that of a comet, suggesting to contain crucial clues about the infancy of the solar system. After 2 years of transit, the Dawn spacecraft finally neared Ceres in early 2015, marking a pivotal event in its mission. As it prepared to transmit the first close-in images of the belt's largest member, the vessel unveiled a world once shrouded in obscurity. Initial snapshots of Ceres depicted a crater-marked surface, pointing to an extensive record of collisions. However, it was the brilliant spots among the dusky, rugged landscape that caught the eyes of researchers and space enthusiasts alike. As the clarity of the photos improved, specialists formed various hypotheses about these spots. Were they ice patches reflecting sunlight, or did they embody something far stranger? Ideas spanned from mineral deposits to potential traces of cryovolcanic action. To everyone's surprise, closer analysis showed that the brightest region wasn't one solid mark, but rather a grouping of several separate luminous areas. The most commonly accepted interpretation was that these were salt accumulations left from evaporated water. This indicated that Ceres might possess or previously possess geological mechanisms that could raise water or brine to its surface, where it would quickly vanish into space, leaving reflective remnants. These observations appended prior beliefs about Ceres, presenting an updated image of a lively, intricate world. The idea that subterranean water or briny chambers might lie beneath the crust poses captivating inquiries into the prospect of extraterrestrial life. Ceres is often called a frosty world with a porous yet solid exterior. Unlike many other asteroids, which are mainly made of stone and metal, Ceres is notable for its rare construction. Its top layer contains a mixture of water frost and mineral compounds like clays and carbonates, making it less dense than its rockier peers. This suggests that Ceres holds a large reserve of water. Its rugged terrain is spongy with ice and other volatile substances locked beneath, making it more similar to a comet than a typical space rock. Experts theorize that Ceres possesses a defined internal structure featuring a slushy outer layer and an ice-enriched core, which constitutes nearly half of its overall mass. This slushy mantle may consist of stone and salty water, surrounding a central mass possibly made of heavy material like silicate rock. The existence of vast ice deposits implies that Ceres may have had liquid water in the distant past, especially if its core was warmed by natural radioactive decay. This inner makeup sets Ceres apart from others in its category and spurs fascinating questions regarding its potential for active geology and how water factored into its evolution. Additionally, the detection of ammonia-bearing clays on Ceres implies the dwarf planet could have initially originated in a colder sector of the solar system before drifting inward. Ammonia can lower the freezing point of water, which might sustain briny fluids on the surface. These findings about Ceres' composition and past expand our insights not only into this intriguing celestial object, but also the bigger picture of icy body development across the solar system. Cryovolcanism is a compelling and comparatively rare natural occurrence, especially next to the fiery volcanism we know on Earth. Instead of emitting molten rock, these so-called ice volcanoes spew liquids or gases such as water, ammonia, or methane. These substances can exist in fluid or vapor form in extreme cold, such as the environment found on Ceres. Cryovolcanoes on Ceres function by allowing briny water laced with dissolved minerals to escape to the surface. When exposed to the vacuum of outer space, the fluid swiftly sublimates, transforming directly from solid or liquid into gas, leaving behind shiny salt deposits. These are the bright patches visible across Ceres.